Hey everyone, and welcome back. Ready for a deep dive into something truly awesome?
I am.
Today we're tackling the chemistry of exoplanets.
Ooh, exciting.
I know, right? We're talking about worlds beyond our solar
The
system.
world's beyond.
Yeah, and trust me, these are way wilder than anything you'd find in science fiction.
I bet. So what are we looking at today?
Well, we've got 5 crazy cool factoids lined up all about the strange and wonderful chemistry that makes these alien landscapes so unique.
The chemistry, huh? That's where it gets really interesting.
Exactly. What I find so fascinating is that this is our chance to completely rethink what we thought we knew about planets.
Yeah.
And maybe even life itself.
You think our solar system might be the exception, not the rule?
It's starting to look that way.
Wild.
Okay, so our first factoid is all about just how diverse exoplanet atmospheres and compositions can be.
Diversity, huh?
It's like walking into a cosmic candy store
Okay, I like where this is going.
with flavors we've never even imagined.
Flavors, so we're talking about totally different from the planets we know.
Right. Completely different from what we see in our own little corner of the galaxy.
So what kind of crazy stuff are we finding out there?
Well, picture this. Hot Jupiter-sized planets.
Hot Jupiter size?
Yeah, basically gas giants.
Got it.
Whizzing around their stars in just a few days.
Wait, a few days?
Yeah, unbelievably close orbits.
That's insane. And then there's those super Earths too, right?
Oh yeah, those are wild too. Massive rocky planets that could be harboring all sorts of exotic materials.
Okay, hold on. Let's back up for a second.
Sure.
These hot Jupiters,
Yeah.
gas giants practically hugging their stars. How is that even possible?
Right. It's mind-boggling. When we first discovered them, it totally threw a wrench into our models of planetary formation.
Makes sense. I mean, in our solar system, the gas giants like Jupiter formed way out in the cold regions.
Right, exactly.
But these hot Jupiters are practically dancing with their stars.
They really are.
How did they end up so close?
Well, the leading theory is planetary migration.
Planetary migration.
Yeah, imagine a young planetary system where you've got this massive gas giant and the protoplanetary disk,
Okay, I'm picturing it.
and their gravitational interactions cause the gas giant to spiral inward.
Closer and closer to the star.
Exactly.
So it's not like planets are just born in these crazy orbits.
Not necessarily, no. It seems like things can get pretty chaotic in those early stages of a planetary system.
So these hot Jupiters are basically rule breakers, huh?
Totally. They defy our neat and tidy solar system model and show us that planetary systems could be way more dynamic than we once thought.
And it's not just hot Jupiters that are shaking things up, right? There's still those super Earths to talk about.
You're right. They're another big mystery.
We know they exist, and some are even orbiting in the habitable zones of their stars.
But here's the catch.
What's that?
We don't know for sure what they're made of.
Seriously.
Are they just bigger versions of Earth? Or are they something completely different? It's a puzzle we're still trying to solve.
Okay, so we've got these planets with potentially crazy compositions, atmospheres, environments. What about life?
The big question, right? Could life even exist on a place like a hot Jupiter?
It makes you wonder what life would even look like in those extreme conditions.
I know. Could it be silicon-based? Could it thrive on radiation? We're so used to thinking about life as we know it.
Yeah, carbon-based, water-dependent, the whole 9 yards.
But what if life on other planets has found entirely different ways to exist?
Exactly. We can't just assume alien life will be like us.
It might be so different we don't even recognize it as life at first.
Whoa.
So how do we even begin to look for something we might not recognize?
That's where the search for biosignatures comes in.
Biosignatures.
Yeah, think of them as chemical hints of life that we could detect in an exoplanet's atmosphere.
Like what?
Things like oxygen or methane. On Earth, those are mostly produced by living organisms.
So finding those gases on another planet could be a clue.
It could, but of course it's not always that simple.
What do you mean?
Some biosignatures can also have non-biological origins.
Ah, so it's not a slam dunk.
Right, we have to be cautious and rule out other possibilities.
It's like a cosmic game of Clue.
Haha, I like that.
We're gathering evidence trying to solve the mystery of whether we're alone in the universe.
And luckily we have some amazing tools to help us.
Like what?
Well, you've got things like the James Webb Space Telescope.
That's some serious tech.
It's revolutionizing how we study exoplanet atmospheres.
These telescopes are like cosmic detectives, right?
They are. They analyze the light passing through a planet's atmosphere, which tells us about its composition, temperature, even potential biosignatures.
That's incredible. It's amazing how far we've come.
I know, right?
From just wondering if other planets existed to actually studying their atmosphere.
And looking for signs of life.
It's mind-blowing.
It really is. It makes you realize how much we've learned in such a short amount of time.
Yeah, and we're just getting started.
With each new exoplanet we discover, we're pushing the boundaries of what we thought was possible in planetary science, chemistry, even the definition of life itself.
It's an exciting time to be exploring the cosmos.
For sure.
But I think we've covered a lot of ground already.
Yeah, we have.
From the crazy diversity of exoplanet atmospheres to the tantalizing possibility of finding life as we don't know it.
Maybe we should let our listeners process all this for a bit.
Good idea. We'll be back soon to go even deeper into the fascinating world of exoplanet chemistry. And trust me, we've got more surprises in store. And we're back, still diving deep into the world of exoplanet chemistry.
Where the planets are weird, the atmospheres are wild.
You got that right. We've been talking about all this amazing diversity.
It's really incredible.
But I keep coming back to this one question.
What's that?
How could life even arise in these crazy different environments?
It's a question that keeps a lot of scientists up at night.
I bet.
I mean, we're so used to thinking about life here on Earth.
Right. Carbon-based, needs water.
Exactly. Thriving in a pretty narrow range of temperatures and pressures.
But what if life on other planets found totally different ways to exist?
Like, what if you've got silicon-based life forms out there just baking on those scorching hot Jupiters?
Or creatures swimming in oceans of liquid methane on some moon?
It's wild to think about.
Life might not always follow the rules we know.
The chemistry of life on another planet could be totally alien to us.
So alien.
We might not even recognize it as life at first.
That's kind of scary and exciting at the same time.
It is.
So does that mean searching for biosignatures might not be so simple?
You're catching on. It's not just about looking for oxygen and methane.
We need to think bigger.
We need to expand our definition of what even counts as a sign of life.
Step outside of our Earth-centric perspective.
Exactly.
It's like those sci-fi movies.
I love a good sci-fi movie.
Where you see these bizarre alien creatures just thriving in places that would kill us.
That would be pretty terrifying.
But it makes you realize how limited our understanding of life really is.
Science fiction can inspire real science, you know?
I think so too.
In this case, it reminds us to keep an open mind.
The universe is full of surprises.
The more we learn about these exoplanets, the more we realize just how much we don't know.
It's humbling.
It really is.
But also incredibly exciting.
Absolutely.
There's so much more to explore out there.
So many mysteries to solve.
It makes you feel like a kid again, you know? Just full of wonder.
I know what you mean.
And, it's not just about finding alien life.
But that would be pretty amazing.
It would. But it's about understanding life itself.
The really big questions.
Yeah, what are the building blocks? What are the limits? Where can it exist?
Exoplanet research is helping us get closer to those answers.
And here's what I find really cool.
What's that?
The tools and techniques we're developing to study exoplanets.
Those are incredible.
They're actually pushing the boundaries of chemistry here on Earth, too.
Oh, absolutely. Think about spectroscopy, analytical techniques, even computational modeling.
All those things are advancing because we're trying to understand these distant worlds.
It's like a feedback loop.
Where the search for the unknown is driving all this innovation and discovery right here at home.
Exactly, and that's the beauty of science.
It never sits still.
It's constantly evolving, always searching for more knowledge.
And as we learn more about the universe around us,
we learn more about ourselves, too.
Our place in this vast cosmos.
It's a pretty amazing journey.
And who knows, maybe one day we'll find proof of life on another planet.
What do you think that would mean for us?
I think it would revolutionize everything.
Everything.
Biology, chemistry, even philosophy.
It's a mind-boggling thought.
It is. Finding life beyond Earth raises some really profound questions.
Like, what would it mean for our place in the universe? How would it change our values, our beliefs, even our sense of self?
Those are questions we can't answer right now.
Not yet.
But they're worth thinking about.
Absolutely.
They're the kind of questions that keep us exploring, keep us pushing the boundaries of what we know.
That's what it's all about, isn't it?
The quest for knowledge, the drive to understand the universe and our place in it.
A journey that never really ends.
Beautifully said. And speaking of journeys, I think it's time for us to take a little break.
A break.
Yeah, we'll be back soon for the last part of our deep dive into exoplanet chemistry.
Can't wait.
Welcome back, explorers. We're about to wrap up our journey into exoplanet chemistry.
It's been quite a ride.
It really has. It's amazing to think how far we've come in just a few decades.
Yeah, it wasn't that long ago that we were just speculating about other worlds.
And now we're studying their atmospheres, analyzing their chemistry, even looking for hints of life.
Incredible.
I know, right? And the things we're finding are mind-blowing.
Planets with scorching surfaces, diamond rain, planets that dwarf Jupiter.
It's enough to make your head spin.
Every new discovery challenges what we thought we knew about the universe.
It's humbling,
but also incredibly exciting.
It reminds us that there's still so much out there to learn.
So much we don't know.
And it's not just about finding new planets or crazy environments.
It's about understanding the bigger picture.
Exactly. The fundamental principles that govern everything.
The laws of physics, the rules of chemistry, how life begins. Exoplanet research is pushing the boundaries of science in so many ways.
We're having to come up with new theories, new technologies to see farther and deeper.
And it's not just scientists who are benefiting.
You're right.
This quest to understand exoplanets is inspiring everyone.
Artists, writers, filmmakers.
Even everyday people.
It's pushing us to imagine new possibilities, to dream bigger, to question what we think is possible.
Science isn't just about cold, hard
There's a
facts.
sense of wonder to it.
The thrill of discovery, pushing the boundaries of human knowledge,
Understanding our place in the universe.
that's what makes this deep dive so rewarding.
We've learned about the incredible diversity of exoplanets, the potential for life beyond Earth.
We've seen the power of human ingenuity, the beauty of scientific exploration, the vastness of the cosmos.
It's been an amazing journey,
It has.
and I want to thank you for sharing your expertise with us.
It's been my pleasure
I hope this has sparked our listeners' curiosity, inspired them to keep learning and exploring.
to keep asking questions.
So to everyone out there, thanks for joining us on this deep dive into exoplanet chemistry.
Keep those minds curious, those imaginations ignited.
And until next time, keep looking up at the stars.
The universe is full of wonders waiting to be discovered.